Hello Business Algebra students, let's begin Lesson 6, Applications of Linear Functions, especially in business. Okay, here we go. The first topic we are going to discuss is cost, revenue, and profit. Let P, R, and C be profit function, revenue function, and cost function. In that case, we must have this relation. The profit is the revenue minus the cost. Simple enough. Next, what is the revenue? Typically, revenue is price times the number of sales. And let's suppose both are functions depending upon some variable x. In that case, you can write those as product of two functions. For example, if you sell 1 million items and the price tag for each item is say $5, then what's your revenue? It's 5 million, isn't it? That's a typical situation that we're going to deal with. This is a bit too general, as a matter of fact. Price changes and sales also changes with respect to some variable x which we don't know. Most of the time, though, we're going to deal with something like this. Price, which is constant, times number of items sold. Just like the example I just told you about, $5 fixed and then 1 million sale. Of course, in general, things will be a little bit different. For example, if you sell in large quantity, price may go down a little bit. So P will not be a constant in general. So we may have a function in the sales that may also be a function. So this is a little bit more general. But most of the time, you're going to get just linear model P times S. Next, cost function. Cost function can be broken down like this. The variable cost plus fixed cost. Fixed cost is the amount of money you have to pay for the rent of your shop, for example, no matter what. Whether you make great sale or little sale, doesn't matter. And the cost associated to, say, baking how many cakes, those kind of things, if you're running a bakery, for example. Those kind of things are variable cost. Most of the time, we're going to deal with this kind of thing. Let's say we are selling, let's stick to S, selling a certain amount, and then variable cost V times S, and then some fixed cost K. That's the kind of situation we are going to be in most of the time. We're going to be doing linear models most of the time. Did I say most of the time? Excuse me, all the time. This is 1000 levels, so linear system only. In general, however, all these are general functions, and even more, they are going to be multivariable functions because there are so many different factors. And you'll have to use the multivariable calculus to do any kind of cost-benefit analysis here. So if you're really serious in quantitative modeling of business, then you have to go a lot deeper than just business algebra. Okay, let's go to an example problem. Stop the playback and read through. Okay, what do we have here? Suppose a firm manufactures MP3 players and sells them for $50 each. The cost incurred in the production of the sale of MP3 players are $200,000 plus $10 per item. So $200,000, that's fixed cost, and then $10 per item. So $10 times the number of items produced in a certain unit. That's going to be the variable cost. Make sense? So variable cost plus some fixed cost, and the fixed cost is 200,000. Now, how about this variable cost? $10 per item, and we are producing X items. Oh, one more thing. Here in this problem, we're producing and selling all of those. So number of production and number of sale are the same. And if they differ, then we have very different situation because we have some unsold items and then somehow we have to store those, and we have inventory cost problems, and that's a little bit different. We may deal with some of those, at least some special version of those in business calculus, inventory costs I mean, but here we're not going to consider those inventory costs. So just variable cost or manufacturing cost plus fixed cost. Well, okay, that was cost. And then what's the revenue in this case? $50 each, and then selling X. So that's the revenue. Simple enough? Yeah, that's even simpler. Cost requires a bit of thinking. We have fixed cost, and then the variable cost coming from $10. Revenue is simple. Price tag times number of items sold. Okay, alright. Now what's the profit? Profit is revenue minus cost. So if I subtract one from the other, I'm going to get the answer like this. Revenue, cost, subtract. Yeah, do some algebra, and here's the answer. By the way, our textbook gives us these nice pictures. So revenue function here, 50x, and cost function here, 10x plus 200,000, and y-intercept here is the fixed cost. And then if you subtract one from the other, then we get this linear function. Okay, and then if I sell nothing, then x is 0, and then subtract 200,000, so y-intercept is negative 200,000. And then if I sell more, then I'll get a little bit more profit. And then at this point, my profit is 0, which we call break-even point. And then after that, I'm going to be profitable. Make sense? We're going to talk about break-even analysis a little bit later, but even here we can talk about it. Yeah, why not? 40x minus 200,000, and then that is equal to 0 at a certain number of sales. And solving this equation, oh, that's easy. 40x is 200,000. X is 200,000 divided by 40. So 200,000. So 20,000 divided by 4. So what is it? It's 5,000. So yeah, 4,000 is here, so 5,000. At 5,000, I'm going to break even. Profit is 0. So in order to be profitable, I have to sell at least 5,000 items. MP3 players here. So we went through a modeling, and then we went through an equation problem as well. Okay, the next topic is marginal quantity, and we're not going to go detail into marginal analysis, and that's something we are going to do in business calculus. I'll just tell you what it means, and marginal quantity is actually the rate of change of the quantity. So in linear model, rate of change is the slope. Here's an example. Revenue is price times sales, so P times X. So marginal revenue is P, the slope. You see, previously what did he have? Is 50x. I'm talking about this example again, $50 each. And then in this case, the marginal revenue is 50. As a matter of fact, if marginal revenue changes, then that itself is a function. But this is linear model, so rate of change doesn't change. It stays the same. The slope, and slope is the price in this case. Here's another example. Cost is variable cost plus fixed cost, and variable cost Qx plus K. And here in this case, what is the slope? Slope is Q, isn't it? Right here. Previously, slope is P, and that is the marginal cost. Just a rate of change with a slope.